The Sporlan division of Parker Hannifin proudly sponsors the Advanced Refrigeration Podcast. There are a lot of questions surrounding the transition to A2L refrigerants and a lot of talking heads disseminating nebulous answers. But when your technician is face-to-face with the first A2L transition project, where do you turn for real-world answers about this specific job? Parker Sporlan's Virtual Engineer is an innovative online design tool to size and select the correct components for climate control and refrigeration applications. Get your A2L system flow and component selection answers in 3 simple steps. Enter your application details, size, and select products, then download your project files. It's that easy. Try it at absolutely no cost. Visit sporlan.com and navigate to the Resource Center. Parker Sporlan, leading the charge.
Been doing
that's just ridiculous amounts of bullshit.
Aren't you hiring someone to do that though?
Yeah, no. Yes and no. The inner cheapness in me is fighting that, but
You're like, I want my dog trained to stop shitting on the floor, but I'm being frugal about it.
well,
I don't see the cat. Did it kill the cat?
No, he's right there.
Okay. I thought you covered the cat in the room.
Yeah, he's fucking huge, dude.
Jesus. Oh, man. Good afternoon, everybody. Welcome to Advanced Refrigeration Podcast. Here are the hosts, Brett Wetzel and Kevin Compass. So how's your week? How's all your fingers and knuckles? I'm sure they're cut to shit.
No, they're just covered in PVC glue.
It's the worst.
Yeah, no, I've been doing case drains all day, so it's just boring.
That's awesome.
Yeah, it's always a great time when you pull a case out. There's just like a wall of mold.
What?
Yeah, it's just every time you pull meat cases out or like cases.
Oh, what are you repiping old cases?
No, we're changing cases.
Oh,
But like behind them's drywall.
ugh.
Yeah.
Not good.
Ugh. You pull them out here, it's like, ooh, shit.
Did you find any hot dogs from like 1980 something?
No. They were there, the rats got them.
It's awful.
Or mice or whatever the fuck is back there.
So besides that, what else have you been doing?
That's about it. This has been like an extremely boring week with no overtime. So just dying inside a little bit.
It's only Wednesday. You have anything else planned for the rest of the week? I'm sure it got screwed up because of that whole Labor Day thing.
No, it's just boring stuff literally all week. I literally want to hang myself. Something needs to fall through something needs to break, something needs to drive a car through the window, knock a case loose. Needs a little bit of excitement.
To think with a holiday, like you would have something fun like that happen. You know what I mean?
I cannot stand easy.
But in the same breath, you're like, this was a shit show this week. I don't want to do this. And then you're like, I'm bored.
Yeah, every week's a shit show, but God, am I bored as shit.
Nice. All right. I figured since we have, I don't know, there was stuff that we were supposed to do, and then I didn't make phone calls, and I also didn't do anything this weekend for once. I literally all weekend, all I did was cook and sleep, and cook and sleep and repeat. That's all I did all weekend. But you guys keep telling me that I need to. Good for me.
Yeah.
I don't know. I thought we'd mess around with I know you're going to make fun of me for it, but mess around with a PNID and talk about that and just follow the flow of a regular, conventional CO2, simple advancer rec. How about that?
Sure.
All right. Don't sound so enthusiastic over it. So you guys have seen this rack before. It's a regular, typical advancer rack with the heat rack. Basically, all I did was just church it up a little bit with flow so we can actually see what the heck's going on here. You want to start off and I'll point and be pretty?
Sure.
Okay.
Let me blow this up.
Do you have it high quality today so it's not all fuzzy?
That's fuzzy. Hold on. It's 1080p.
Oh, your internet just sucks then.
Okay, so I always like to start on these guys first on the medium temp side. So I think it's easiest to follow it that way. So you got your medium temp, 2 compressors here. They're Copeland's.
I hate you. I hate you so much. I have to make a note. Go ahead, continue. Just saying, that's the thing that we're supposed to be together.
Oh yeah, I forgot about that. Whoever, you ruined the last one.
Oh. Misinterpret things that I say. It's fine. It happens all the time.
It's okay when it happens to you, but not to me.
No, I just need to remember to go back to delete what you just said. So then people talk to us. That's the problem. We're not like, hey, so people don't want to talk to us.
Oh my God.
Continue. Go ahead.
All right. Leaving here, you got your discharge line, which is in red. If you follow this discharge line, you go to this incredibly small oil separator that he put on this incredibly small PNID diagram. It's the world's tiniest temp, so it comes into this oil separator. Generally, it's going to be your first spot on here before you go anywhere else. Okay, you go into your oil separator. Out the bottom of your separator, you have your oil drain. So that's going to your reservoir. We'll go over that in a second. But let's stick on the high side. So leaving the high side, you have what looks to maybe be a check valve. Can't tell. Probably.
No, right there?
No, where the arrow is. So it's just an arrow, but should be a check valve there.
No check valve. Ball valve. No check valve.
All my racks have check valves.
This one doesn't.
That's dumb.
Just saying it doesn't.
Okay, so
maybe it's here, incredibly tiny, like the incredibly tiny template.
Yeah, this is incredibly tiny. So you have a distribution block on here where they use to grab transducers, a gauge, your line feeding, your hot gas dump. So it's just a manifold block that Hill Phoenix uses. Actually quite nice. Tons of room. It's not as easy to break a transducer. Packed angle valve. Coming off that, you have what looks to be the high pressure relief.
Yes.
Real irritating that isn't on a manifold tree.
Yeah, you know what it probably is, because then you'd have to put 2 of them there. You know what I mean? So it's just more simplistic to put one and then make you blow down the system in order to do that.
Yeah, unless you're like me and you swap out a controller and you go to fire it back up, and then said controller locks up in the middle of booting and the rack goes instant high head and blows the relief. It sticks. It popped once and sticks and just drains the whole thing.
That's not good. Not fun.
No.
After the teeny tiny relief, this is where we have what would be where the heat reclaim would be set up. So we have a 3-way valve here. I'm not sure what type of port. I've never taken apart that valve, so I don't know. So apparently they make 3 different types of ball valves. One is just open shut, and the other one's a regulating. I guess it has to do with the type of port that's actually inside the ball valve. So they have what's called like a teardrop port, which I think is the one that they use it's for mixing. So essentially it would be but I'm assuming it would be for the heat reclaim.
Okay.
And that's being controlled. So typically these are usually hooked up to a flow CES unit. Typically how those work is the controller itself is looking for a heat reclaim. So it wants to keep the temperature up, so it can keep the air conditioning on. So what it'll do is energize a relay output, and then that will then close the set of contacts, which will send a DI over to whatever your BMS system would be. So whether it be Danfoss, whether it be CPC, whatever, then at that point, how the controller is set up, typically they try to maintain with the 3-way valve, trying to maintain about 15 pounds of differential across to keep your flow within that heat reclaim coil. And then back out, I'll pass it over to you for the gas cooler.
So you're going into the gas cooler, just like a standard condenser would be. So you're coming into the top of the gas cooler and you're coming out just like a normal condenser, and you're coming out your drop leg. Okay, you fall on your drop leg back, and you're going to get to what would be your high pressure valve. But it looks like that. I can't tell because it looks like a very poorly made picture of a Danfoss valve.
This one right here?
Yeah.
No, that's CCMT 16.
Wow.
It's tiny.
This is not your best work.
Oh my God. You want me to zoom it in? I can zoom it in.
Oh, it's okay. So
This
this is not what I expect from you, but okay. So coming out of there, get your high pressure valve, guys. High pressure valves get a couple jobs here. Okay. Your high pressure valve main job, when it's subcritical, is to maintain subcooling. Okay, on the condenser. So it's maintaining a subcooling set point given by whatever EMS controller or valve driver, whatever's on there, is maintaining the subcooling. Okay, so that is its job when it's subcritical. When it's transcritical, let me back up real quick. Its secondary job when it's subcritical is to maintain receiver pressure. So it has to drop the pressure on the high side back down to receiver pressure in order to have stable liquid and safe working pressure for us in the store. So we could use the cheapest copper known to man. So we have to drop the pressure down from, say, 900 pounds down to 500 pounds, 515-ish. 515 is a magic number. So we need to drop it down, and in order to do that, we need to hold back some pressure while we vent some pressure out of the tank. So that's its secondary job, is to drop that pressure down. Its third job is to protect that tank at all costs. So it's trying to protect that tank by closing down. If the pressure gets too high above a certain threshold, whatever controller you have that's controlling that high pressure valve, once it gets to a certain threshold over the receiver, it's going to start limiting the valve, then start closing the valve to protect the tank from popping the relief. Now, when we're transcritical, we're trying to maintain a subcooling value, but with a false, what does it keep switching back and forth?
Sorry, I was looking for something while you're talking.
A false, whatever value that whatever EMS system thinks it should be at. So if it's iPro, they switch to pressure and they run off a pressure set point. If it's Danfoss, they're running off of the COP chart set point, wherever they think that pressure needs to be when it's transcritical via whatever drop leg temp is. So it's,
hold on, sorry, real quick reminder. You have, Copeland has their own PT chart where there has that algorithmic PT chart that it works off of. It could be, I think a couple different publications do have it out there. It comes on a lot of Hill Phoenix stuff because they predominantly do a lot of Copeland stuff. Danfoss, if you're curious to what that algorithmic PT chart essentially is, if you use the Danfoss slider, because Danfoss actually doesn't, I can't think of the word, they don't publish the actual chart. So you're stuck with, hey, this is, I was trying to write it down the one day trying to figure out how the hell it was, but essentially it uses that PT chart on there. So it does have, most PT charts like PT Pro do not have anything as far as after the critical point, after 87.8, it'll tell you to go pound sand. But if you use the Danfoss slider, it'll actually give you the algorithmic PT chart where they think is going to do the best after the COP.
yeah, no, it's all like a guessing game with that. So wherever it needs to be. So it's whatever manufacturer is using that to drive their stuff, however they want to do it. Now, the thing is with that, it all depends on whether you're transcritical or subcritical, how it's controlling. So leaving that valve, we drop down the flash tank, which is going to be your receiver. So coming out of the top of the receiver is the secondary valve. This valve has one care and one care only. This is your flash gas bypass valve. It only cares, it's selfish. It only cares about the receiver. It's all it's looking at. It's looking at receiver pressure. It's opening and closing to maintain receiver pressure. It doesn't care about any other value in the system. It doesn't care about Flood back doesn't care about high pressure in the drop leg. It only cares about itself, and that's the receiver. And that is venting to your medium temp suction.
Do you want me to bring up the different stuff that both valves, how they work in conjunction, depending on what kind of alarms they have?
Yeah, we can go over that.
All right, hold on.
I'm sorry that the truck backing up just like totally made my brain stop.
I'm sorry. My bad. Damn boy. Oh, what the hell is your problem? So this is an instance of what's going to happen when you have a low flash tank pressure. The reason why we keep this pressure up in this flash tank is for a couple different reasons. Two predominantly. One is to make sure that we have a good differential between our liquid flowing out to our medium temp and the return, to make sure we have enough differential to keep flow from the flash tank to our medium temp suction. Otherwise, no bueno. The other reason why a lot of times the flash tank essentially is used almost like as an OCV for the oil system. So a lot of times, including on the system we were just looking at, the oil reservoir basically uses the flash tank has its pressure guide. So if the suction is at 400 pounds and our flash tank's at, let's just say 520, it's making sure that the oil reservoir is staying at 520 psi. The reason for that is because then we'll have enough differential to push the oil from the oil reservoir out to the actual medium temp and low temp suction. So if something happens where the flash tank gets too low for whatever reason, it will then try to compensate for that. In this instance, the flash tank is set for 525 psi. If it starts going all the way down to about 475, the BGV will start to shut. And then it'll start to close down if it starts hitting about 475. At that point, this will start increasing in percentage. The HPV will start to increase in percentage, essentially to keep feeding more gas into there to try to keep the differential. A lot of times, even with Danfoss, you'll see where it'll say pressure gas cooler, and then pressure gas cooler reference. Basically, these two are what it's supposed to be doing and where it's currently at. It'll forego what it's supposed to be doing and typically go to its max opening percentage. I had an instance when I was training out in Idaho where this valve was deadlocked at 65%, but the BGV was set to zero, was set for an opening percentage of zero. That's because the BGV was faulty. The BGV couldn't close, and so it was just trying to continually feed more gas in through the high pressure valve to keep that flash tank pressure up. And that's essentially how that works. We also have another instance that can happen. High flash tank pressure. What, Kevin, you were talking about before, where the BGV, if God forbid this part of the system is at, 1,400 pounds currently operating, and the flash tank starts to increase dangerously close to whatever the release is set for, essentially what will happen is the BGV will try to open, if it can, and basically go all the way up to 100%. And then to combat a lot of that, because it doesn't want to hit that high pressure threshold, it's going to start closing down the HPV to basically limit the gas to the flash tank. This is a separate option, the decrease compressor capacity. That's an option within the pack controller that you don't always necessarily have to do, but it is an option. But when this is employed, you should be utilizing MOP on a lot of your box controllers, your case controllers, because as we start decreasing the amount of compressor capacity, our suction pressure is inevitably going to go up. If we keep letting the suction pressure go up, eventually we're going to pop a relief. At least this way, if we start decreasing the compressor capacity, then we can start shutting off via the MOP alarms, via the case controllers, to basically start shutting down some of the actual cases themselves to help reduce that load. And it's doing this to basically try to get this under control. Maybe it just got out of whack for whatever reason. Maybe it's doing it because this valve is stuck at maybe 20% and it can't open up any further because it's mechanically bound, or the valve just took a shit.
Yeah, no, that was a good explanation. Or maybe the flash tank is just bricked up when it goes to start. So this is something that when these racks are sitting off for a while, that it gets hairy, because if your if your receiver pressure is too high, the flash gas bypass valve is going to be pegged wide open. If your suction pressure is high, it's not going to do anything. And then if your discharge pressure is high, it's going to instantly high head, because it's going to not open the HVV because the receiver pressure is too high. So there may be a situation where you have to come in here and actually manually force the valve or blow on some of the receiver pressure to get the high pressure valve to start opening, so you can get some flow in the system. Because until you get the flow in the system, you are SOL.
Yeah, and you've said this before, if the high pressure, if the sensor for the gas cooler is sitting baking out in the sun, it's going to think that it's a lot hotter than what it is. And so it's just going to keep staying shut, trying to raise that pressure until it actually cools down. Or what you've tricked it to do sometimes is spray with a little bit of duster to get that thing down in temperature, so it tries to relieve that pressure out of there. And like you said, eventually what's going to happen is, if the flash tank gets even heavier again as far as pressure, it's just going to start closing that valve down again. So that's the rack that you helped me out with, where basically the flash tank was real high. I couldn't get the rack restarted, and essentially it was all because there was a sneaky, stupid alarm in there that basically shut down the rack if the rack had low superheat. So if the rack shuts off, the suction pressure is high, the temperature of the suction line is high, it thinks it has 0 degrees of superheat, and it's going to say, nope, I don't want to start, we're flooded. But it actually doesn't know what the hell's going on. Sneaky alarms.
Yeah, no, it's that'll get you. So here's the other issue, and you may need to blow down some of the high side. So that's the other thing with that, because if you don't blow down the high side, it's going to be an issue sometimes, because you may not have enough pressure to escape to start it. So you may need to blow the high side down 800 pounds.
And this goes back to, I know you make fun of me for talking about this all the time, but utilizing the fucking MLP alarms, letting the cases shut down in case the suction pressure keeps elevating. That system that we were talking about the other week, they had the MLP alarms set for higher than what the flash tank is actually set for, or I'm sorry. They had the MLP alarm for the case controllers set higher than what the relief pressures were on the freaking rack. So we checked out the pressure. The relief pressure on that rack was 650 PSI. The MLP alarm was set for 672. So I was like, oh, we're not going to start shutting down cases until we're actually blowing the refrigerant. That makes a whole hell lot of sense. Dumb.
Yeah.
All right, let's finish out the PNID then. So just be mindful, because like we were just discussing, there's internal alarms that can affect how these valves operate. How many times have you've been on the phone with someone, troubleshooting with someone, Kev, and they're so focused on the high side because they have a high side alarm, but all that stuff we were just discussing, it was actually a high flash tank pressure that basically caused the high pressure alarm, but they didn't know because they didn't read through the layers and layers of manuals that are out there.
Today's episode is sponsored by the RefRushield RDP Series differential pressure monitors from Westermeyer Industries, now available for transcritical CO2 systems in addition to other common pressures and refrigerants. When the filter element of your coalescing oil separator is contaminated, it can hurt your system's performance and efficiency. But how do you know when it's time to replace that filter? Wait too long to replace, and you could end up with a nasty filter blowout. But replacing too often can be a waste of time and money. The answer is installing a differential pressure monitor. The RDP Series differential pressure monitors, including the new Transcritical CO2 model, are available now from Westermeyer Industries. To find out more information, email sales@westermeyerin.com. That's WESTERMEYERIN.com.
Yeah, exactly. There's all kinds of issues there with these controllers that they could cause other issues. High suction pressure, high discharge pressure, high, you name it. Any of those could lock this out permanently. So this is where you guys got to really pay attention to whatever you're working with. Like in the iPro, they call it HS the HSP or HSPSA. It's really, I forget what it is named. It's in the receiver set points. There's a high alarm and there's a pressure band where it starts to limit the high pressure valve opening for the flash gas pressure. So this is where you got to really pay attention to whatever EMS system you're using. Now, okay, so if we start to look at our medium temp suction, okay, we got our suction coming back from our cases. And then you have, I don't know why Advancer does this. I think it's a horrible idea, is putting the suction shells with liquid cores in them.
Why?
Because they get loaded with oil and they have a pressure drop.
Oh, good reason. Why is the oil leaving then, Kevin?
Why is the oil never not leaving the CO2 rack? It might as well be a screw rack at this point.
Oh, by the way, speaking of oil leaving, we're going to do a podcast with Mr. Chapman about their centrifugal oil separator. They're doing some studies right now and it's looking awesome.
Dude, that thing, I tested it when it first came out. That thing kicks ass.
The centrifugal?
Yeah. I'm sold on that.
No, it's the fact that it alleviates how many oil issues are accommodated for shutdowns on CO2 systems. A bunch. Because once the system has a complete oil failure, guess what's happening next? Relief events.
Yeah.
So let's continue down the line. When you're doing a startup, you can run this thing until you get the flash tank down to design pressure that you're trying to. While you're charging this thing up, you have a full refrigerant system going on, a full cycle. So you have your suction line, discharge, going through the gas cooler, going through the high pressure valve. Remember, the high pressure valve is going to generate a little bit of liquid and a little bit of vapor. That vapor is going to be left over. The rest of the vapor is going to be expelled through the BGV valve, going into the suction of the medium temp compressors, and rinse and repeat. And this is the prime time to make sure, after you did all your pre-checks, to make sure the sensors are right, sensors in the right location, and that your valves are actually working. Now, at that point, you should have already checked to make sure that they were wired correctly, but this is the prime time to make sure everything is operating optimally before we commit to actually send liquid down to the rest of the system. Because once we do that, we all know it opens up a couple different cans of worms. Two other parts of the system that we talked about briefly. Kevin had made mention this little manifold here. Not only is it having the high pressure gauge as well as the pressure transducer on there, but we also have a hot gas injection on the Advanced racks in this particular system. It's used for two different purposes. One, it's done for hot gas injection for superheat mitigation. If the superheat gets too low, we can inject a little bit of hot gas to raise that temperature up. The other purpose of it is for loading control. So if, God forbid, the suction pressure starts delving down too low, we can inject some hot gas to raise the load up to keep the compressor running so we don't keep short cycling our compressor. You have to look at the programming per controller. I think it's usually 230 to 240 PSIs when they start cutting in the hot gas, if I'm not mistaken. Yeah.
Yeah, I end up lowering it.
And when would you typically see that? Is when one of the big loads on the medium temp decides not to be there, or if one of your major low temp loads cuts out as well?
Yeah, you're talking about the hot gas bypass, right?
Yeah, they probably have it set for two reasons: the superheat and the pressure. When would you see it? When do you ultimately see it?
Both. Oh, yeah. I usually end up setting about 340 pounds, 350 pounds. Try to keep it.
So you raise it.
Yeah, I try to keep it so it catches it before it crashes.
Gotcha. Before it actually becomes an issue.
Yeah, so I'd rather start injecting while it still has some money to pay.
before it runs out of coin.
Yeah, because at 200 pounds, you're useless. You're out of coin.
Yeah.
No good.
No bueno. And then over here, we also have, besides the liquid feed for our flash tank, we also have a liquid feed here for liquid injection. So that is also for superheat mitigation. So if the superheat gets too high, let's just say we start getting in the 35, I don't know, I want to say 40 realm, 40 degrees of superheat, you can start injecting a little bit because you're still, even if you're running at a saturated of 20 degrees, 40 degrees higher than that is still 60 degrees, which is Yeah, it's not 65, so you're good. But if we start delving any higher than that, we can start injecting a little bit of liquid to bring that superheat down.
Yeah, the liquid injection on the hill racks is like pissing through a straw. Same with the hot gas. It's almost too small.
Not enough.
Not enough. You shouldn't need it to a point. Liquid injection, it seems like it never needs.
Especially if the low temp compressor shuts off, you know what I mean? Because then basically you're left to your own devices. Because it depends also. We talked about this before, where if you have a massive pressure drop going across your BGV, especially if this starts delving down lower than the set point, lower than 400, you cause that higher pressure drop. And I don't know how many times guys are like, I'm getting a low superheat alarm, but it's not coming from the cases. Where's it coming from? The only other place that it can come from is that BGV. That massive pressure drop is creating a little bit of liquid molecules, and ended up putting a low superheat alarm on Mr. Compressor over here.
Yeah, it comes in waves. It hits when you get a little bit more load on the medium temp, like when you get some cycling on compressors. That's when you'll notice like the superheat diving all around. The other thing I want to bring up is when I say the liquid injection doesn't work, I take that back. Liquid injection works fine at these racks. It's the hot gas injection that's too small. It's way too small.
I was told the reason why they did that is because it's the port size. And if they go a bigger port on that DN2, then basically it's going to derate the valve and it wouldn't be applicable to hook up to the system. That's what I was informed. But I do see on a lot of the newer Advanced racks that they're starting to put two twos together, running two valves in parallel to help combat that a little bit.
You could cook a steak on the one that Zero Zone uses. Like, that thing flows enough hot gas to false load the rack.
Different manufacturer, though. I don't think
it is.
These are high lock. These ones are high lock, right?
Yeah. Which I'm very upset with high lock with their stupid strainers.
Actually, I have one of my. I started carrying a box.
I have cleaned so many of those. Like, I had one rack. I must have taken it apart 60 or 70 times cleaning it. And they stopped sealing it for a while. The other thing, guys, I don't know what he's doing right now. He just threw him on a tangent. So on these racks, these Advanced racks, you want to make sure you keep these filters. Keep an eye on these filters, because if you don't keep an eye on these filters, I hate that. Useless fucking strainer.
It works. Continue. I knew it was going to give you PTSD.
So on that, you want to make sure you keep these filters clean for the suctions, because if they get loaded up with oil or they get loaded up with debris, they get a pressure drop pretty quick. And 5-6 pounds doesn't seem like much, and it's really not a ton on CO2. But you start getting 10, 15. Then you start restricting oil back, and you'll notice like them loading up with oil. So you want to make sure those filters stay clean.
Gotcha. You'll also notice we're going to talk about the low temp right here. So you have the low temp basically discharging in the suction, which essentially makes this a booster. You'll also notice that the low temp suction actually comes through the core that he was just talking about, makes a pit stop within a heat exchanger that's within the flash tank. And this is one of the most confusing things, because it's like, wait a minute, why is 200 pounds going into a flash tank that's 500 pounds? That doesn't make any sense. But not knowing like that there's an actual coiled up heat exchanger in here, basically exchanging a little bit of energy here. And the reason for that is if you have case controllers and the case controllers are running at, let's just say 8 degrees of superheat, these low temp compressors do not like 8 degrees of superheat because of super oil carryover. So we want to try to get that superheat up to about 36 degrees. We can do that by basically... What?
36 degrees is disgusting.
Manufacturer spec. It's what they want.
Disgusting.
That's what they want. That's what they want.
Cold compressors are happy compressors.
Yeah, but also oil carryover compressors are not happy compressors. So we try to keep it.
They're going to pump oil no matter what.
It doesn't matter if it's if it's fucking Copeland. It doesn't matter if it's Bitzer. They all tell you 36 degrees of superheat on
these might as well be screws at this point.
Oh my God. Andre's probably on his ass, fucking laughing his ass off while vacuuming. Guarantee it. Guarantee it.
think of it like this. Until they go to centrifugals, it's going to be nonstop oil carryover. It's the truth.
No, when you said centrifugals, I'm like, compressors?
CO2 and
oil
centrifugals are like a match made in heaven.
Yeah. Need any more information? Talk to Adam Chapman from Westermeyer.
But the low temp, I struggled to even get superheats below 40 on some of the low temps. Like it depends where it is. Like it's a struggle to even get them down low enough.
Wait, you said below 40?
Yeah, below 40 degrees of superheat.
I like 36. As long as we're at 36, no one cares. We're at 40.
Yeah, I want medium temp compressors that aren't cooking themselves.
Medium temp 20. Low temp 36.
You struggle to get to 20 on the low temp, medium temp most of the time because you have to FG flash gas bypass valve. I will die on this hill, and the medium temp suction to drop leg heat exchangers are like the greatest thing ever.
Needs to be a fucking must. What he's referring to, you ever looked at an enthalpy chart because you got nothing else better to do? You'll notice that the line at the top where it's above the dome where you're running transcritical basically will stop and then go down. That's your gas cooler outlet temperature. If you can get that temperature farther over to the left, not that left. If you can get over to my left, basically closer to the left-hand side of the enthalpy chart, you'll be able to actually create less flash gas. You'll have a better quality liquid coming out of that high pressure valve. So a lot of times what they'll do is this medium temp suction, before it actually goes right back to the suction of the header, will make a pit stop up through a heat exchanger that takes a little bit of energy from here. Then that way you can run your 8 degrees of superheat. And I've seen it 3 different ways. I've seen it where it does the whole system, where it basically exchange everything between the the medium temp suction and the BGV. I've seen it where it just does the BGV, whatever gas is coming off the BGV. And I've also seen it where it just does it off of the suction. So there's 3 different methodologies. It makes a lot of sense to do it off of the flash tank of the BGV, but I've also seen it where they take all of the load through there and they just basically do a 3-way mixing valve to set that for a superheat. So whatever energy they can get, as long as they're maintaining their superheat back at the medium temp compressors, who freaking cares? It's going to raise that temperature up to where the superheat needs to be. I'm not going to have to worry about oil carryover because I do have the right superheat.
Oh, you're still going to have oil carryover.
Once it runs transcritical, typically we do. We gotta have Adam. Actually, you know what? That would be a good conversation. Having Adam come on talking about what happens with
oil carryover at different discharge temps
and with coalescing oil separators and some of the trials and tribulations that they've uncovered.
I will say this: we're going over the heat exchanger and how great it is. It's only that great if it has hot gas injection. Also, if it does not have hot gas injection, and that is the only means of superheat reheat, it's shit to me. Because here's the problem: in the wintertime, there's no load and drop leg to do your reheat, so you kind of lose that. So you need it for when you hit the spring, fall, and your like shoulder seasons, wintertime. When you're running a real cold drop leg, you may be the opposite. So if you're running 50 degrees on your suction return temp, 40 degrees, okay, and you're running 50-degree drop leg, 40-degree drop leg, you aren't going to be getting any reheat out of it.
See, this is something that I would like Vinan to talk to you about, Bob, because basically I always tell him about, why don't we have this? Because you don't need it. If you size the heat exchanger properly, you don't need it.
I've seen it in multiple rack manufacturers fail because there's no heat.
It would be an interesting conversation. That's all I'm saying, because he will die on that hill just as you will die on your hill. So
we're going down the cool gas, hot gas thing. Oh, it's latent heat. It's latent heat, but the coil's still defrosting for 45 minutes now instead of 10 minutes. You can't tell me it's better.
Doesn't do it for 45 minutes.
Bullshit.
It does not.
You throw a big ass coil on there. Yeah.
Maybe you're not setting up the differential.
Okay. That's like saying the below freezing hot gas defrost with CO2 works great. It don't.
I want to say something so bad, but I can't.
But I'm being serious though. If you're designing a rack, please put hot gas injection as a backup for when it's super cold out. You need it.
Listen, I'm going to be starting up a rack here in, I think, March, and it doesn't have it, and it's going to be March in Texas, so I'll get back to you. Dude,
Texas, so was going to get down to 50?
No,
for like 60?
no. I'll get 20. Don't say that because you've been up
20 degrees.
Yeah,
Get real.
talk to your brothers. They'll tell you.
One day out of the year, it's going to get down to 20.
No,
And then the whole place is going to shut down.
No,
everybody's going to.
How many times do I get fucking stuck somewhere in January? It's usually when I'm at AHR. Every single time, and has nothing to do with me flying into DFW. It has nothing to do with me flying American. This is strictly, there's been at least 3 times now out of the 4 times I've been AHR where something happens where all of a sudden we have a miraculous fucking ice storm or snowstorm, and my ass is not getting home.
Your guys' version of a snowstorm is like a dusting, and
I'm not. Listen, I agree with you. It is a dusting, but a dusting to Texas where they're used to just having stones and dirt and dust. And yes, I agree with you. But when you don't have the apparatuses, basically the salt trucks, in order to accommodate that, it becomes an utter wasteland of soccer moms ended up getting in accidents because they think they're
nobody knows how to drive in Texas.
Yeah, they're 4-wheel wagoneer can. Oh, I can do ice. No, you can't.
Oh, but I will die on the hill with the hot gas injection. If you're going to do the heat exchanger, you need both. You need both. Why not? It's cheap.
I'm gonna have Bob do the engineering. If you have a 60 degree or 55 degree drop leg temperature, and he's going to argue the point. Well, if you have a properly sized heat exchanger, you won't have those problems. Okay, I can just hear him say it now.
And then if everything's working mint properly in the store, and there's not a iced up case here, and there's not a valve hanging up here and there, and it's been properly maintained by people who care.
Also, it's the whole market thing. It's the whole supermarket thing. We have it because it's designed for the load, right? The load that we have, but
the load is never there.
And that's what I was about to say. Like we have the rack running at a 16 degree suction to maintain our lowest case load of 18, but all the rest of the freaking loads are 28 degrees. So most of the fucking cases are shut off. And that's what I try to explain to him.
I'm like raising the SST to 22, even though it says 16 because the lowest case needs 18, but I'm running plus 22 and it's still shutting down.
Properly designed. If you were to put EPRs on those, we probably wouldn't have those problems.
Like, I don't understand why Hill Phoenix derates their cases so much.
What do you mean derates them?
Like, they're way more efficient than they say they are.
You can get like a 3 degree TD out of that thing.
Yeah. There's cases that say that they're like a 5 to 7 degree TD. It's more like 2 degrees. Keep that fucking strainer away from me. I hate the thing. Dude, I've taken so many oil baths with that damn thing.
At least the last rack I was on, it actually had valves going to the suction header, so you didn't have to blow down the whole section.
It happens so many times. I bought a swage lock valve, and I cut it in on both sides of it.
What do you mean?
With the stainless, where it's got like the fucking, it's like the stupid swage lock fittings where they're like,
it's like just a ball valve.
Yeah, it's a compression fitting. I put it on both sides because I got so tired of fucking draining down the reservoir every time.
It's a pain in the ass.
It's a pain in the ass. One extra ball. Like, why put the fucking check valve there? It never seats. Ever. I've never been able to get the check valve because there's a check valve on that line in between there. It never seats. Ever.
You're talking about the one. So that's fucked up that you said that because I said that to someone the other day and they're like, no, there's not. And I was like, no, I'm pretty sure like most racks always have a check valve going from the top of the oil res into the flash tank. And this rack that I was working on.
Well, there's a check valve. There's a check valve on most of those racks. Leaving the oil separator, like post solenoid valve, there's usually a check valve right before it goes in the reservoir. Little tiny pancake looking check valve. Never get it seat ever.
Dumb.
Yeah. Take an oil bath. Like doing that high lock strainer is an oil bath.
Stupid oil bath.
Yeah, thank God it's not PAG oil.
All right, once again, I'm not going to say anything. All right, have a good day, and see you guys next time.